Okay, we find ourselves some trig identities in our new three functions, cosec, sec and cot, by starting with sine squared, cos squared, added together equaling 1. Now we have two options here. We're either going to make the first term the number 1 by dividing it by itself. So sine squared becomes the denominator of all three terms. Or we are going to divide the second term cos squared by itself to make 1. So think of that in your mind as your goal, to make one of the terms the number 1 by dividing by itself. Now if we go and we rearrange or relabel the equations, cos over sine is cot, so cos squared over sine squared is cot squared. 1 over sine squared is cosec squared. And sine over cos is tan, so sine squared over cos squared is tan squared. We rearrange these equations, we get two brand new identities. So we could use these identities to simplify something like you see on the screen now. We make cosec squared the subject of one of our equations above and substitute in what you have on the other side. And if you do that, it comes out as just negative cot squared. The angle inside 5 theta doesn't change, so it has to stay consistent throughout. With an example like this, we're just trying to make sec the subject of the equation. So we pull sec up from the denominator to make sec squared, and now we've got sec squared. We should be thinking about this identity here. At this point, we make the substitution that sec squared equals tan squared plus 1. And we would go on and square root and get positive and negative and find our answers. Okay, final example. This is a quadratic trig question in disguise. First thing you've got to notice is that cosec and cot are both in the same identity. What you're going to do is change the squared term into cosec squared, and that's going to give us a quadratic in cosec. We will then solve for cosec by factorising. And once we have cosec as the subject, we reciprocate both sides to get sine. And we go on and we find our solutions from there.